Okay, so if you want to graph this, how do you want us to get started? What would you do?
Dude, I'm not gonna hold you. I do not. This is at the beginning of the year. I don't remember really that much of this.
Okay, well, any equation you want to graph, what's the first thing? What's one surefire way we could get
Oh,
started?
find the X point and Y point, or I
Yes,
coordinate.
make a table. Right. So give me some numbers you want to plug in.
Um,
Easy numbers.
two,
Okay, maybe smaller.
one,
Okay, even smaller.
0,
Okay, good. Right. And some negative numbers, right?
and then -1, -2.
Perfect. Okay, so those are usually a good set of numbers to start with. Now,
Yeah.
if you plug in zero, you get zero plus two, which is two, then negative two times two is negative four.
hmm
Plus two, you get negative two. So you plot a point, right?
Yeah.
But we plug in one, you should get four, negative eight plus two, negative six.
Yeah. hmm
But negative one, that actually goes away, so you get two.
Yeah.
So don't give up too soon. Just always plug in a number if you're not sure. Well, negative one, comma two. Yeah, it looks like it's having a slope of four. And then if I plug in, let's say, negative two, you get negative four plus is negative two. Also, that's two. So you get back to negative two again. So it looks like it's following a V shape.
hmm
Yeah, I could plug in two, but it's just going to keep going down. So I expect something kind of like this. Like, for example, if I plug in negative three, I should get negative six. So given how the graph looks now, where's my vertex?
Vertex is right there. So I'm two, -2, 1.5.
No, it's we plotted the point already
Yeah. Oh,
from
yeah.
the
I'm seeing.
table. You want to get from the table.
Yeah.
So which of these points from the table will it be?
Hold on. A 2-0. Or nope. Oh, it's -1, 2.
Good. So it's just right there. Um, and it kind of makes sense because if you pull the two out from the inside the absolute value, it kind of
Yeah.
looks like this. So, and of course, so it's going one left, two up. Okay, the y-intercept, where's it crossing the y-axis?
Wait, can you repeat that? Sorry, you cut out a little bit.
Where's it crossing the y-axis?
On the y-axis, it crosses at 0. No, no, no. Hold on.
Just look at your
Negative
table.
2, -2.
So you want to say zero comma negative two.
Yeah.
Okay. The line of symmetry.
Mm-hmm.
So it's the line that cuts in half.
Yeah.
So clear is going to go through the vertex because that's where it's cut in half. What will be the equation of that line?
Mm-hmm.
What will be the equation of that line
Of
that goes right through the middle of it?
metal.
Well, it's a vertical line.
Yeah, so it'll be just 2.
Well, hold on. Where's it crossing the x-axis, this vertical line?
Crosses at 2. I mean -2.
No, no,
You
no. Well, my vertex was this, negative one comma two.
Oh, so it's -1.
Yeah. And you're going to say x equals.
Uh-huh. All
Okay.
right.
Definitely do another one because I think I want you to work out the kinks here. We'll get to the x-intercepts in a moment because that's a little complicated. The range are the y values that you can get.
They're negative.
Well, hold on. So what's the highest y value here?
Negative 2.
Two, and we're going up or down.
Down to -6.
Well, it goes down forever
Yeah,
actually
down forever, but like, yeah.
because you can plug in so many numbers for x.
Yeah.
So y is less than or equal to two.
Mm-hmm.
Okay, the x-intercept is where it crosses the y-axis. Sorry, it crosses the x-axis when y is zero. That's not terribly obvious. I mean, we could, if I try drawing this a little better. So it goes down four right once. And my guess is
Mm-hmm.
probably negative one half and negative three halves. But the best way to prove it is to
Mm-hmm.
actually solve for x.
Mm-hmm.
To do that, you replace y with 0 and isolate x. If you do that carefully, move the 2 over, you get this. Divide the -2, you get 1.
Mm-hmm.
So 2x plus 2 equals 1, or 2x plus 2 equals -1. So 2x equals -1. Yeah, I do get -1/2, comma
Mm-hmm.
0.
Yeah.
I could also get, if I subtract 2, divide 2, -3/2, comma 0.
Mm-hmm.
So those are my x-intercepts. So, okay. So we won't do 2 and 3 because there's other topics to talk about. I mean, if we have time, we can come back and do number 3. And I know we're meeting again soon. But let's try this again. So I'll make a table. Now, before we get too carried away with choosing the x values, usually it's a good idea to see what makes that 0 on the inside
Yeah.
and just pick numbers above and below it.
Mm-hmm.
If I do that, 3x would equal -6.
Yeah.
X would equal -2.
Mm-hmm.
So we probably should choose numbers above and below it. Actually, so we do -1 and 0,
Mm-hmm.
and -3 and -4. So that's usually a good idea.
Yeah.
So if I start with -2, I'd like you to plug -2 in for x and tell me what you think y equals. So if I replace x with -2, what's y going to equal?
-6.
Okay, keep going. You got to work it all out.
-6 plus 6 minus 3. So 1/3. So it's -2. Hold on. 0, -2. -2 minus 3. -2 minus 3.
Well,
Uh,
hold on. Slow down, slow down. So you're
ooh,
doing 3 times -2. I like that. And you can add -6 plus 6. I like that.
yeah.
What's -6 plus 6?
0.
Okay, great. What's 1/3 times 0?
0.
Okay. And what's 0 minus 3?
0. Oh, -3.
Good. Okay. Now let's try. Yeah. So just be methodical about it.
Yeah.
Are you allowed to use a calculator at all? Or
I think.
like a four function calculator, or
Yeah.
you are?
I think I can, yeah.
We'll find out for sure because if you're not, then you have to just make sure you can do the mental math.
Yeah.
Um, okay, let's plug in say -1.
Mm-hmm.
Plug in -1, what happens?
Oh, -3x plus x. It's 3. 3.
Okay.
That's 3.
And
So,
-1/3 of 3,
it's -1.
and -1 minus 3,
Uh, yeah. +2.
-1 minus 3.
Oh, dude.
Taking 3 away from -1.
Oh, -4.
Good. Now here's the deal. You're going to expect symmetry. So you could plug in -3, but
Mm-hmm.
because I'm choosing values above and below -2, I know that that's going to be symmetric. And it looks like every time x changes by 1, y changes by 1. So I could probably expect this to happen, -5 and -5. So you can always plug in for yourself, but by being very intentional finding the vertex, it gives you a pattern or a system to follow that's reliable. So the vertex I know is going to be -2, -3 because I deliberately set the inside equal to 0. That helped me find the vertex. So -2, -3 is right here.
Mm-hmm.
Then I plug in the other values, and see it just becomes more efficient this way. And line of symmetry is x equals -2. Y-intercept, of course, is 0, -5. There are no x-intercepts because it's not crossing the x-axis. And the range is y is less than or equal to -3. So by doing it this way, we kind of zoom through the process pretty fast. So you have this as a video to watch. So I'll let you do number 3 on your own. If we have a chance, we'll get to it at the end, but that's what we could discuss on Thursday. Okay, so piecewise. So I like this. So we could do 4. I'll tell you, show you an efficient way of doing five, and then six, leave up for you to do. Okay. Do you remember how to do piecewise?
Piecewise, not really.
Okay. Don't overthink it. You just have, you got two or more equations. You have y equals 3 halves x,
Hmm.
and you have y equals negative 3 halves x. It looks fun with the braces and the inequalities. Don't let it fool you. It's things you've done before many times. If you graph y
Hmm.
equals 3 halves x, how would you
Yeah.
graph that?
Um, y
You
equals
can,
3 times
you can always make a table. So plug in
it's
easy numbers.
2, 1, 0, negative 1,
Well,
2.
hold on. Let's do zero first. But I don't want to do one because it gives a fraction.
Oh, yeah, yeah,
But
yeah.
maybe two is good, and maybe four is good.
Well, 2, because then if we do 2, we will be able to, oh,
Well, hold on. If we plug in zero, what do you get?
0,
Plug in two, what do you get?
6/4.
Nope. What's 3 halves times two?
Uh, hold on. 4, 4.5.
Okay, slow down. 3 halves times two.
3, 5.
Okay. How do you multiply fractions? Because
So it's
two.
like 2 over 1 now, I
Okay,
guess.
good. Okay, then
Just
how do
do
you
that,
good?
and
And then
then
how do you multiply
it'll be
fractions?
3 on the bottom, and then 4 on the top, 4 over 3.
No, well, no. Slow down. Slow down. Dude, you're going too fast.
Yeah.
Okay, 3 over 2 times 2 over 1. How do you multiply fractions?
You go across.
Okay, what do you mean by that?
Oh, so it'll be 6
6
over 2.
over. Good. You always multiply numerators and
And then 3 over
denominator.
1, you reduce it to 3 over 1.
So it'll be 3. Good. Okay. Yeah, you're doing some weird stuff. I don't know what you're
No,
doing.
no, I was doing I was doing something wrong. I was doing like a different method. I was thinking
I
about
think you were confusing with another topic, like cross
yeah.
multiplying, but we don't
Yeah,
have
cross mode,
equations
that's
of,
exactly what I
but
was
we don't
thinking.
have, the reason why I know what you're doing. You're relying on your memory, like some of you've seen in the past, but your
Yeah.
memory is going to fail you because what's going to happen is you're going to remember something that has absolutely no relevance to this
Hmm.
because you're not understanding what is happening, right? You have to understand that this is just multiplication, not solving, right?
Yeah.
It's doing something completely different. So we have to make sure the task at hand is to multiply. So if I plug in four, what do you get?
Be playing 4.
So 3 halves times four. So same thing, just
The
multiply the
same thing
numerators.
doubled,
So
honestly. So it's
yeah, so it's
12
12 over
over
2.
12 over 2, so it'll be 6.
Correct, right, okay. Yeah, because you doubled x, so that makes sense. Okay, so the graph looks like this
Hmm.
if you were to graph the whole line. But here's the issue. You only want that line when x is less than negative 2.
Hmm.
So these values I plugged in for x clearly are not less than negative 2. So they're
Hmm.
not really valid for what we're trying to do
Yeah.
here.
Yeah.
So what you could do is just say, okay, well, at least I know how the line looks, but really let's plug negative 2 in first,
Hmm.
which I know makes that negative 3. And it's a whole because it's not included. And then if we go down 3 over 1, down 3 over 1. So it's like
Hmm.
that. Let me erase this junk here. So that's what happens. You're graphing a piece. That's why it's called piecewise.
Yeah.
Okay, now let's look at the next piece. Let me get rid of this junk here. Okay, so you're graphing another line, but it's and same slope. So y equals mx plus b is usually a good way to graph lines because
Uh-huh.
then if you find that y-intercept, what's the y-intercept here? If you plug in 0 for
Um,
x, where's it
2,
cross
negative 2.
negative 2? Good. But you want this when x is larger than negative 2.
Hmm.
So if I plug in negative 2,
Yeah.
and the slope is negative 3 halves, so down 3,
Yeah.
right 2. But it does start at negative 2, so I'll start it up here. So if I do plug in negative 2, I do get, I think, 1. Yeah, 1. And
Mm-hmm.
it's closed because it's included.
Yeah.
So you get that.
Mm-hmm.
And that's your piecewise function.
All right, sounds good.
So very important for piecewise functions, they also have to pass the vertical line test. Meaning if I
Yeah.
drew a bunch of vertical lines, only crossing once.
Mm-hmm.
So I've had students like again, they're memorizing, not they're not understanding. I've had students in the past say, "Oh, I don't know, it just maybe it just looks like that," and like they just are not really careful about it because they figure, "Oh yeah, greater, it's got to be above," and they're not really thinking clearly. Well, that clearly fails the vertical line test. It has to be
Yeah.
a function, and again, you want the x values on that portion to be greater than or equal to -2.
Yeah.
So all the x values on this portion of the line have to be larger than -2. So the domain was it's all real. So the range looks like it has a highest y value of 1 and goes down forever. So range is always good. Just you just look at the graph itself. Domain could probably look at the graph itself, but you can also just consider what x values you're going with. And it looks like no x values are excluded. So that's what's happening with piecewise. So now we're
Mm-hmm.
going to do this a little more efficiently. And I can help you guide me here. Okay, so what do you expect this graph to look like? 4/3 x plus 8. What kind of shape is that?
Up.
No, what kind of
Positive.
shape? What kind of shape is it? What kind of is it a line? Is it a V shape? Is it a parabola?
Oh, probably V.
Well, hold on. It's 4/3 x plus 8. We just did this.
Oh, so it's a line.
Yeah, it's a line. It's y equals mx plus b. What's your y-intercept here?
Y-intercept is 8.
Good, good. Which slope?
4/3.
Up 4, right 3. But
Yeah.
it's supposed to be starting at -3. So by putting -3, it should be 4. So
Yeah.
go this way,
Mm-hmm.
and it's open.
Yeah.
Okay. Okay. Then we graph this.
Mm-hmm.
No, I didn't quite do it accurately. Do you need anything, Dad? Do you need anything? Oh, okay, okay. Okay. Next up, you have a V shape, right?
Yeah.
Okay. So you want to kind of embrace the vertex form.
Mm-hmm.
So but are you allowed to formula sheet at all for your final?
For my final, yeah, he'll give you one. He's gonna give me one next class.
Okay,
I
he probably might
I
give this right here. This is the vertex form. So H and K are the X and Y coordinates of the vertex respectively. So when you see +1 and -3, the +1 is going to help you determine H. So what do you think H is? If you see X plus 1, what would you put in place of H to make it X plus 1?
oh,
What would H have to be to make this X plus 1 on the inside?
uh, gone.
It's
Has
really simple. Just have X minus H equals X plus 1. X's cancel. What does H
oh yeah,
equal?
it goes 0. Well,
No, no, no. Negative H equals 1. So what does H equal?
oh, a positive one.
No,
Wait,
if it's positive, it would be -1 on the left side.
oh, so it's negative one. Wait, I'm
Correct.
tweaking.
It's -1. Right. So set the inside equal to um, X minus H, and you solve for H. So clearly it's -1. Okay. And then -3 is on the outside, so that's K. So
Mm-hmm.
that's your vertex, -1, -3. Um, which actually no, doesn't line up. No, it's just no, it's -1, -3 is right here.
Yeah.
Let me just make sure I'm doing this right. Okay. Then the slope is 2. So up 2, right 1, up 2, right 1, um, up 2, right 1, up 2, right 1. And then also crap, I messed this one up. Supposed to be at -1. There you
Okay.
go. And then, yeah, put in -3. That's 2. Wait, something seems off. Oh, crap. I messed up again. -1, -3. Try it one more time. Um, Here we go. It's down here. Did -1, comma 3. Gosh, what's wrong with me today? -1, -3. Sorry. There we go. Put in 3. Yeah, you get 5. Okay. And the next one, if you plug in 3, you get 1.
hmm And then I think honestly, for today, let's just focus on this stuff because what we work on last time, factoring, I got
Okay,
I'm like pretty expert on it. So let's just focus on that on Sunday, like
sure.
reviewing factoring.
So we go down 2, right 3, and you get that. So essentially, what you're doing is you're graphing each equation according to the condition you see there.
hmm
And if there's no equal sign, put a hole. If there's, make sure it's a filled in dot. Make it a little more pronounced here.
Yeah.
Yeah, and that's what we get. So the domain is still all real numbers,
hmm
and the range is going to be looks like the highest y value is 5 and goes down forever. So again, it's using transformations of whatever function you're dealing with of y equals mx plus b. So you'll 6 will have to do on your own. Okay, let's talk
hmm
about functions now. So these should be very straightforward. I mean, if you miss these, you're going to miss it due to carelessness, really, more than anything else.
Yeah.
So remember, whatever's inside the parentheses, what you plug in for x, and the function for f is -3 minus 2x. But it's negative on the outside, so I'll put a negative bracket,
hmm
-3 minus 2 times -3. I kind of protect it there. Minus 2 times the h of -2 is 1 minus 3. So it's negative of -3 plus 6. 1 minus -6 is 7.
hmm
So it's -3 minus 14. You get -17.
hmm
So you got that.
hmm
So just really just a lot of plug and chug. Let's look at 8. So in this
hmm
case, some of these involve letters. So um, actually, hold on, let me
hmm
come back. Yeah, because it was H, right? Okay. So H and -a, so that's 1 minus 3 times -a,
Yeah.
plus 2 times g of -2.
hmm
So I'll put a bracket here because you got through the 2. G of -2 is -6 minus 2,
hmm
plus f of -2a.
hmm Um,
So yeah, it's a very kind of just very kind of dry, very boring problems. Nothing too crazy. We could probably just walk through a couple more here than 11, 12, how to try on your own. So for 9,
mm-hmm.
-2. Now, what's the G function here?
Uh, X, so 3.
What was that? Sorry.
Oh, 3, 3x minus 2.
Right, and what's your X value inside here?
Um,
Inside the G function in the problem?
2.
No, no,
Oh, no, 3, 3, 3.
no, no. What is inside the parentheses for G?
Oh, negative 2a.
Right, right. So you're gonna do 3 times -2a
Yeah.
minus 2
Oh.
plus 3. Okay, now f of 3a.
Mm-hmm.
So let's look at the f function. Okay, the f function's right here. So what are you gonna plug in for x?
Mm-hmm.
What are you plugging for x?
Well, for X, hold on, sorry, let me just mute this. My, the cross group chat that for school. Let me just, I don't know, let me figure out how to mute this real quick. Second. All right, there. All right, so can you repeat that? Sorry, it's just my computer's very loud.
Yeah, no. What are you gonna plug in for x?
Job 3x minus 2.
Yeah, but what for the f function? What's inside here?
Oh, 3a.
Good. Okay, but we have to simplify it.
Mm-hmm.
So let's now go through the simplification process.
Yeah.
So if we go through the simplification process, let's look inside the bracket. So here you have 3 times -2a minus 2. What is that? How do you clean that up?
3a.
What's 3 times -2?
3 times negative 2. Negative 6.
No, 6a minus 2, okay.
Mm-hmm.
And let's clean up here as well. -3 minus 6a. Okay, then you distribute. What's -2 times -6?
Negative 2 times negative 6. Times negative 2 times, positive 12.
So 12a plus 4.
Mm-hmm.
And then what's 3 times -3?
3 times negative 3 is positive 9, I mean positive 9.
-9. And then 3 times -6a,
3 times negative 6a is
-18a.
negative 18a,
Okay, then let's combine like terms. What's 12a minus 18a?
negative 6.
Good. And then 4 minus 9?
5. Negative.
Right. Yeah, these are problems you should not miss. These are actually free points. Just you gotta be careful.
Yeah.
Okay, let's try one more. Let's do 10. I'll have to do it up here because it's space. Let's switch colors, bit of contrast. All right. So -2. So f of -2 is going to be -3 minus 2 times -2
Mm-hmm.
minus 3g of -3. Um,
Mm-hmm.
so if you plug -3 into that, you
Yeah.
know it's -9 minus 2
Mm-hmm.
minus h of -1. If I plug -1, I'm going to put parentheses 1 minus -3.
Mm-hmm.
So if I clean it up, I should get -2, and that's -3 plus 4, -3 times -11, and minus 4.
Mm-hmm.
So it's -2 plus 33
Mm-hmm.
minus 4, so that should be 27. Mm. So yeah, so that's 10. Okay, let's keep going. So 11 and 12. We'll have you do it on your own. Let's look at 13. You said factoring are pretty solid, so we could probably bypass a good chunk of that. We could do graphing of parabolas. Um, okay, so let's look at this. This is a behemoth of a problem. Do you know what EB stands for?
Hold on. EB, I get it now. Um, expected. I don't know.
Give you a little hint here. What am I drawing?
Arrows.
Okay. The arrows are the middle of the graph or the ends of the graph?
Oh, and bottom
Ends. Okay, so it's end. Okay.
end.
And what do you think the B stands for?
What
It's
is it?
not bottom. It's not bottom because if something's going to be pointing up, right?
Oh yeah, and ba no,
Yeah, go. You got said end.
base.
No, you almost said it.
Ball.
So we're looking at how the graph can operate, right? Like something's going to be pointing down, something's going to be pointing up, right? So we're looking at the end. What is it called? And I'm sure your teachers mentioned in class.
And no, you probably didn't. He teaches like some like different methods.
No, no, no. He's taught this. Trust me. I'm almost certain he's taught this. This is an essential in algebra too.
Hold on.
You almost said it.
Hold on, let me think. Hold on. I got this one. Hold on.
I'm writing on the screen.
And behavior, I think.
Yeah, see?
Yeah.
And behavior. So you're looking at the ends behave.
Oh yeah.
So now how do you guys write end behavior? Do you guys write it as like as x approaches infinity or how do
Yeah, for infinity, yeah, X
okay.
approach.
So you're always going to write this as x approaches negative infinity, we'll start with that. Y approaches something, and as x approaches positive infinity, y approaches something. So if you think about it, when x approaches negative infinity, we're looking at the left end. Is the left end
Mhm.
pointing up or down?
It's pointing down.
You can say negative infinity for y, because y is going towards negative infinity. Now the right end, are we pointing up or down?
Down.
So we're going to say the same thing again. Negative infinity. Now x-intercepts, we look at where it's crossing the x-axis,
Yeah.
and that should be hopefully pretty obvious. So I'm going to label it.
Yeah. hmm
So how many times am I crossing the x-axis?
How many times am I crossing X-axis? I want four.
Okay, what are those values?
Um, uh,
We'll start at the far left. What's that going to be?
zoom.
Just count it.
Yeah, hold on. Wait, one,
One,
two,
two,
three,
three,
four,
4, 5,
six,
6. So -6,
-6. Yep.
-4,
Yeah.
0,
Uh-huh.
and 4. Okay, and let's look at the y-intercept. Now, where's across the y-axis?
Usually cross the y-axis.
So what's the y value of this green dot?
One.
No, one would be right here.
Ne negative. Oh, zero.
Here, right. Okay, so 0. Okay, relative max. Do you know what that means?
Relative max, like the average or
Nope.
hmm,
What does it mean to be a max?
like you're like as far as it could go or
Far,
like you're
far what? High or low?
high.
Yeah, exactly, because the max is high. So we have two high points
Yeah.
or two peaks.
hmm
So this peak looks like it's at -5, comma
Uh-huh.
3.
Uh-huh.
Yes, -5, comma 3.
Yeah.
And let's figure out this one. This one's a little tricky, but So it looks like that's 2.5
Yeah.
and about, I don't know, 14.
Yeah.
Here ultimate will be a low point.
Mm-hmm.
Looks like it's -2 comma -8, looks like. No, -6. Okay.
Mm-hmm.
Um, Now the max, I think what they meant by that was absolute max, which is kind of dumb because 2.514 could be can count as both, but we'll just go the absolute max. Now increasing, what does it mean to be increasing?
What does it mean? Like, it means like it's gradually increasing or
So where in the graph is that happening?
uh it's happening at the most bottom point.
Well, let me, are you able to write on the screen or scribe? If you can circle to me where the graph is increasing on the graph.
Well, the graphs in like hold on, can I where's your pen?
Yeah,
Right,
you should be able to see the annotate button.
like right here. That's like the main increase.
Yeah, that is part of it. It's where think of it this way, it's kind of like a roller coaster.
Mm-hmm.
So if you board the roller coaster on the left side, we're going up the roller coaster, right? And then we hit the high point of the roller coaster.
Oh, so
Well,
it's just all the way up there until it reaches its max point.
right, correct. And then
So
when there's a transition from max to min,
two all the way
then we're
down.
dropping. Actually, let me color code it with green being increasing and red being decreasing. So that might be more intuitive. So shoot, that's not what I wanted. Here we go. So see, that's rising, and it's also
Yeah.
rising. You see how this is dropping
Mm-hmm.
and also dropping. Okay. So we're increasing from negative infinity. Actually, you haven't learned that. You could say it's increasing. So you want to get the x values that are associated with that. Definitely when x is less than -5. Also when x is between -2 and looks like 1 or 1.5.
Mm-hmm.
Hold on. 2. Yeah, from -1 to 1.5.
Mm-hmm.
So then from, oh, that's not -5. That's like, sheesh, they made it so weird. That's -2.5.
Yeah.
So it's decreasing from -2.5 to -1.
Mm-hmm.
And from 1.5
Mm-hmm.
and forever.
Mm-hmm.
The graph is positive, so it's positive when we're above the x-axis. So we want to get the x value. So like it looks like from here to here, which is definitely from -3 to -2,
Mm-hmm.
and from 0 to 2. Negative, obviously when x is less than -3, between -2 and 0,
Mm-hmm.
and from 2, x is greater than 2.
Yeah.
The range, the highest is like looks like it was 14. So y is less than 14, less than or equal to 14. So you're just analyzing the graph like crazy. So that's the analysis there. Um, I do want to talk about factoring because I mean it is a big part. I want to make sure it's okay. But before we do that, let's again we'll do two of these graphs. You know, one I'll kind of have you guide me, one I'll kind of show the efficient way. 20 I'll have you do on your own. Um, all right. So 2x squared plus 4x minus 6. What may help is to pull the 2 out.
Yeah.
If I pull
Mhm.
2 out, what's left behind?
You pull two out there, oh, it's
Mhm.
just x squared plus 4x minus 6.
No, yeah, I pull the
Oh
2
no,
out
plus I don't know, x squared plus 2x minus 6.
minus.
Four, well, four, but I don't know how, oh yeah, four, 'cause you're just pointing out the two, yeah.
Well, hold on. I pulled 2 out from this. So yeah, 2x squared plus 4x minus 6. I pulled 2 out. You had x squared plus 2x minus.
Six.
I
Or,
pulled 2 out.
no, it's four then, minus four.
I pulled the 2 out. I divided by 2.
Oh, three.
Right. Be careful.
I
Right,
thought
right.
you're
Remember,
taking it two out, so you're just minusing two.
no, I said took a 2 out. 2 out means you're dividing. You're never
Alright.
never
No,
subtracting.
because one of my teachers, they said that, but he said that like, in addition, like, I think he was like a little slow though.
No, just we're pulling it out. Okay.
Alright, so.
So you could factor this.
Mm-hmm.
How do you factor it?
Well, you could take x out.
No, x squared plus 2x minus 3. We break it
Okay,
down.
so that's 2x squared.
So what multiplies negative 3 and adds up to 2?
It's easy. Negative 2 and negative 1.
No, multiplies negative 3 adds up to 2.
Oh, oh, negative 3 and negative 1.
Negative 3 and negative 1, that's positive. That multiplies positive 3. So multiplies negative 3 adds up to 2.
Oh, 3 negative 1.
Good, thank you. So you have x plus 3. So the reason why I'm doing this work, that's why factoring is a skill that you want to have mastered because you need to apply that skill for this problem here. That
Yeah.
will help you to figure out the x-intercepts, which is pretty easy on negative 3 and 1, because if you set the equation equal to 0,
Mm-hmm.
when y is 0 essentially, x has to be negative 3 or 1. So that's where I'm going to cross the x-axis. My axis symmetry is going to be right in between,
Mm-hmm.
which of course is negative 1. X equals negative 1. The y-intercept, if I plug in 0 for x, we should get negative 6.
Mm-hmm.
So it'll be down here. The vertex, because now I have my axis symmetry by finding the vertex by plugging negative 1.
Yeah.
Plugging to the original or the factor form, probably factor form is easier. That should be negative 8.
Yeah.
So let's switch colors here. Not sure what's meant by a mirror point, but maybe something that mirrors the y-intercept. So you could say negative 2 comma negative 6. Of course, it's 0 comma negative 6 here. And of course, that you can write that as negative 3 comma 0, 1 comma 0. And the range is y is greater than or equal to negative 8. So yeah, that's how you can graph it. You can
All
also
right, sounds
graph it
good.
by doing x equals negative b over 2a, which is helps find the x coordinate of the vertex if we can't factor it. But if you could factor it, that'd be more advantageous because then you could use logic to get everything else.
Yeah.
So
All
like
right.
for 27, so now we'll just a little more efficiently. What's common? What's a common factor you can pull out?
2x or 2.
I always want to keep the leading term positive, so I take out negative 2.
Wait, so, okay, you show me the factor that's normally I could do this pretty
So
easily.
so if you divide it just by negative
No,
2, what do
no,
you get?
can I technically just do a negative 2 times negative 8, and then that's positive 16?
You
Um,
you could do that.
I like
But
doing that. That's why I did on the test and I got a pretty good
but it's
grade.
more complicated if you keep the leading term negative. It's easier if you pull the negative 2 to get x squared minus 4x
Alright.
minus 4. Sorry, minus 4x plus 4. That's gonna be easy to factor, right?
Yeah.
So how do you factor that?
Oh,
You have 4 and negative
bro, that's
4.
pretty easy. Wait, hold on.
What multiplies the 4 and adds with negative 4?
It's negative 2 and positive. No, it's Dude,
Adds, it says multiplies a 4 and adds up to -4.
multiplies to 4.
So
Negative 2,
-2,
negative
-2,
2.
-2, right? Correct, yeah. So that's 2 comma 0.
Yeah.
So x equals 2.
Yeah.
Y-intercept is 0 comma -8.
Mm-hmm.
So the mirror point would be 4 comma -8
Mm-hmm.
because you're going across that axis symmetry.
Mm-hmm.
X-intercept is obviously is just the vertex itself. Y is less than or equal to 0. So that's how that's done. So 28, I'll have you try on your own. We can wrap up in a few minutes because it's almost 10 o'clock. Just to do a little more factoring practice, maybe just
Back to
we could just try 14, 15, and
it's
then
pretty
the
easy.
rest will have to kind of work on. We'll discuss on Thursday. So when you have four terms, you can do
No,
factor by
14.
everything.
No, we're never gonna. Oh, this is my practice test.
What's that? It's on here if we should talk about it. What?
Dude,
So,
my factoring test, there's no forward question problems.
well,
But all
just talk
right,
about it.
let's
So what's common between 9a squared, 9a squared x
9.
squared, and not so 9a squared? Go a little more than that. So it's x squared minus 1. And what's common between 4x squared and 4?
Um,
4, right?
yeah,
So it's x squared minus 1.
yeah,
So it's 9a squared minus 4,
yeah,
x squared minus 1.
yeah.
And you could break that down further as 3a minus 2,
Mm-hmm. Mm-hmm.
x minus 1, x plus 1. Then here, so what multiplies to 24 and adds up to -10?
Mm-hmm.
So give me two numbers that multiply 24, add to -10.
Uh, it's pretty easy. Hold on. 6 and -4.
So they're both negative.
Oh yeah, say no, -6, -4. Yeah. Sorry.
But because the leading term's not 1,
Yeah.
you
And
do need
then what do
a,
you do? Wait, oh, it's
so,
pretty.
so
Oh, this is so easy. Hold on.
you
Let
could
me.
do a box or
Okay, no,
factor
no,
by
I don't
grouping.
like that method.
Well,
So what I did on the
what do you
test,
like to do?
but let me just can I just explain this real quick?
Sure,
So I
go
did
ahead. Good.
6 times 4, and that's how I get 24, and then I
Okay.
do x squared minus -6 minus 4, and then I put two parentheses around the x squared and -6, and then the -4 and +4.
Well, actually, hold on. I think you meant this. 6x squared minus 6x minus 4x. Do you mean
Yeah,
this?
no,
Okay,
yeah.
okay, that's good. Okay, that works.
And then you put
So
parentheses over the 6x
okay,
squared.
okay. That's
Yeah.
fair. That works. Okay. And then what?
And then you just take out 6x from that one.
Good. So what's left behind?
Um 4x plus 4 or x.
Well, in the first group, but
Oh,
after you
just
pull the
x
6x,
squared.
x minus 1,
Yeah.
and then here you can take out -4,
And then it's me x
x
plus
minus 1.
oh,
Jeez, why did I do block? That was dumb. Um, so 6x minus 4
yeah.
and x minus 1. But I probably could pull the 2 out earlier, but if I pull the 2 out, that's fine at the end.
Mm-hmm.
So 3x minus 2, x minus 1, and there you go. All right. Cool. Okay. So I think that's good. That's a very full session we had today. So definitely the ones we haven't gotten to, I'd like for you to work on those and we'll
All right, sounds
discuss.
good.
Yeah, so we'll do more procs to this.
All right.
I'll end this recording and I'll see you. Hold on. It's going to be at 7. No, wait. Thursday. You're meeting at 8. Let me double check. Hold on.
Yeah. Oh no, it's a 4 o'clock.
You're right. It's 4 p.m. Correct.
All right,
Right.
sounds good.
Right.
All
Okay, I'll
right.
see you then.
Have a good night. Bye.